Okay, it's working now. All right. So we're going to convert each equation to exponential form. So we're going to go backwards. So when I look at the log base 3, the 3 becomes the base for my exponential equation. What's the power?
4.
4, and then equals 81. So these are pretty easy to do if you have all numbers. So 3 to the 4th equals 81, you could actually check. And then for the next one, it's the exact same thing, so we're going to cross that off.
Oh, I did it too.
Twice?
Yeah.
Okay. So let's move on to the next one. All right, so this next one we would have 6 squared equals 36. So this number becomes the base, 2 becomes the power, and then 36.
That makes sense.
If they put fractions in here, it's actually just the same thing. So for the next one, I'm going to have 1/2 and then squared. So I need to put parentheses on the 1/2 before I square it. That way we know we're squaring the top and the bottom. And then we can take the parentheses off the 1/4 when we put it in the answer.
Okay, so would you be mad if I wrote that as a decimal, not a fraction?
You have to leave it in the form that it is.
Uh-huh.
So you can't change it to decimals in the middle.
Okay.
Now, if you were solving a story problem, you could. If you were trying to do stuff with a calculator, but for this, you just need to keep the numbers the way they are. All right, so we're going to use that idea to evaluate logarithms. So on each of these, we're going to put equals x. Okay, so we're going to make this into an equation, and we're going to solve it by putting it into exponential form. So then I have 2 to the x power equals 16. I just have to figure out how many times I have to multiply 2 to get 16. So 2 times 4.
What?
And then 4 times 2, and then 8 times 2.
Oh,
So yes, it would be 4. So x comes out to be 4 because 2 to the 4th
Ready?
is 16.
Get eaten by a gorilla.
Okay? On the next one, we have 3 to the x power equals 1. This is a special case. There is one power that can change any number into 1. What is that power?
0.
It is an exponent of 0. Anytime, so you could check 3 to the 0 power is 1. Okay, anytime you have equals 1, this is going to be 0. All right, so let's look at the next one. So I have 10 to the x power equals 0.1. So this is now a decimal. You could also think of this as 1/10. You could think of it as decimal or fraction to solve this. So what power of 10 changes it to 1 over 10? Negative 1. So this would be x equals negative 1. All right, so for the next one, I have 2 to the x power equals the square root of 2. We didn't really have a lot of this on our last exponentials lesson, so I will remind you that in order to get a square root, you have to have a half power. X would be 1/2. So if I had 2 to the 1/2, that's the same thing as a square root. 1/3 is a third root, 1/4 is a fourth root. All right, so now we're going to go down to where some more equations, but they may have x in different places. So we have log base 7 of 49 equals x. How do I write that in exponential form?
What? Oh, it's going to be 7 equals 49.
7 to the x equals 49. So what power of x makes 7 into 49?
7.
So 7 to the 7th power would be really big. It would be 7 squared. So x must be 2.
What just happened?
Okay, now they're going to start putting the x in different places. So how would I write the next one in exponential form? X to the third equals 8. So now I have to figure out what base times itself 3 times is 8. So that would be 2. So 2 to the third is 8. So x would be 2. All right. So down here, this one takes a little bit more thought. So I'm going to have 2 to the x power equals 1/8. Now I'm going to rewrite 1/8 for a second because we just saw that 2 to the third was 8. This is 1 over 2 to the third. So I can replace 8 with the power of 2. And then I can figure out, okay, what power of x makes it a third power in the denominator?
Probably like -3.
It would be -3. X would be -3. So 2 to the -3rd would be the same thing as 1 over 2 to the 3rd, which is the same thing as 1 over 8. Next one, we have 3 to the x power equals -9. Think about that one carefully before you answer. What power can change +3 into -9? A negative power just flips it over. It does not make it negative.
1/3.
1/3 makes it the cubed
1/2.
root of x. 1/2 makes it a square root.
I don't know.
It doesn't
Negative
work.
uno times 2 squared, the 11.
Not possible.
Okay, and this is important for you to know. Anytime you have a negative right here, there is no power of a positive number that can change it to a negative. You can make it into a fraction. You can make it into a radical. You cannot make it negative. So you cannot take logarithms of negative powers.
I put trick.
Okay? So this limits the domain of our logarithmic functions. So when we do graphs, we'll have some asymptotes that you'll get to see where that happens. All right, so going into inverses. If you have a logarithm of a base and an exponent that has the same base, and they're all in the same problem like this, log base b of b to the x. The log base b and the b cancel, and you just get x. Okay? The same thing happens if you put log base b of x into the power of b. It just becomes x. So this is showing you that logarithms and exponents are opposite operations. So down here where I have log base 4 of 4 to the 3rd, I don't need to do 4 to the 3rd because the log base 4 of 4 is all going to cancel out. I am left with 3. Every year people miss these on the test because they forget how this works when they try to do weird stuff on their calculator. It just cancels. This all cancels. Since I have 2 as this base and 2 as this base, it all cancels.
Why is it 2?
I get 5.
Why does that one cancel?
Because the base is 2 and the base is 2.
No, I was talking
So
about-
here the log base 17 of 17 to the 2x all cancels. You get 2x. We don't know what x is, but that's what we can put down as an answer. What would be this next one? 3x. All of that cancels because they both have log base 9. This last one's a little tricky.
0.
So it's not a 0 power. If I have 6, that's 6 to the
One.
first power. So your answer would be 1 because the log base 6 of 6 cancels.
I got that one.
So if I give you another one that says like log base 12 of
Log base
12, the answer is just going to be 1.
How would you solve for the x?
On which one? On this you couldn't because I didn't give us an equals anything. But we will get to equations where you have another side. You'd have to have an equal sign somewhere and another side of the equation, which we don't have.